Here's a tutorial on how to conduct a repeated measures two-factor analysis of variance. In this scenario, every participant has experienced each of the conditions. In this case, we have a Stroop test where the color name and the color word is either congruent, so the word red is written in red font, or it's incongruent where the word red is written in yellow font, and you need to state the color of the font, not the word. It's a well-established finding in psychology that we have slower reaction times stating the color if the font and the word are not the same compared to if they are congruent or the same. In this experimental design, participants had words that were congruent and words that were incongruent, either when they were standing or when they were sitting. And this is to look to see if posture affects how quickly they can complete this task. Now, in this we have 50 participants, and there are two factors, congruency and posture, and each of those factors have two levels. Now, to begin with our two-way ANOVA, we first may notice that if we look here, there's little a's written here. I'm going to show you what happens. If I go to Analyze General Linear Model Repeated Measures, I'm going to say posture is 2, so sit, stand, and then congruency is 2, incongruent, incongruent, defined. Now watch, I try to go over here, it says string variables are not allowed on the list. So I'm going to have to cancel that out, go to variable view. Over here where it says type string, I need to click on string and change it over to numeric. This is just a little data quirk. This is not a rare occurrence by any means. SPSS just interpreted those numbers as string information and not numeric information. So now we'll go again to Analyze, General Linear Model, Repeated Measures. We got posture and congruency still hanging out there. And so here we have ones and twos. So the first number has to do with the first factor. The second number has to do with the level of the second factor. So this means posture 1. So we're going to say standing is posture 1, and then congruency is 1. So stand is the level 1 for posture, congruent is level 1 for congruency. Now we need posture level 1, so stand again, and congruency level 2, incongruent. So then we put incongruent, stand. Now here we want to have the second level of posture, which is sit, with the first level of congruency, which is congruent. So congruent, sit, second level of posture, sit, with second level of congruency, incongruent, sit. Now we will go, we don't need to worry about doing any contrasts or such because we only have two levels, but because we have an interaction that is possible here, you can go to estimated marginal means. Posture and congruency, again, because we're just dealing with two levels, we don't need to do comparison of main effects, but we can compare posture and congruency, look at posture and congruency, compare simple main effects. I like SIDEC. LSD is too lenient, Bonferroni is too strict. I feel like SIDEC is the Goldilocks choice for power correction. So click that and then plots. Let's get ourselves a graph. So we can go over to posture on horizontal axis, congruency on separate lines, click add. You can do a line chart or a bar chart. We're going to start off with a line chart with a standard error of 1. Oops, I don't need to do that. Click 0. Okay. So here we have our multivariate tests. These are tests of the intercept, and we're just going to skip over those. We don't need to worry about sphericity because we only have two levels within each factor. If we have more than 2 levels, then we need to look at the significance level here to determine which row to use with within subjects effects. So because we only have 2 levels, you'll see that the findings are identical throughout the different rows because there's no sphericity to correct for. So we have our within subjects effects. Our degree of freedom for posture is 1 because there are 2 levels, and -1, 2 minus 1 equals 1. And we can see that there is a significant effect of posture. For congruency, again, our degree of freedom is 1, and our this difference is highly, highly significant. And then we can also see that there is an interaction. So that means that posture's effect and reaction time varies depending on congruency or vice versa. And because you multiply the degrees of freedom of the main effects to get the degrees of freedom, 1 for the interaction effect, 1 times 1 equals 1. Our error row here tells us the degrees of freedom for the interaction term. As you can see, it's 49. This stays consistent here because you multiply the number of participants -1 times the number of groups or factors involved. So you can see there's a significant effect here. So we're going to definitely want to follow that up. We don't have any between subjects, so we just skip over that. Here we can look at the means, and just looking at these means, you can see that from congruent, which is level 1 for congruency, to incongruent, it's longer for both of them. But both of these seem to be shifted a little higher and be a little longer for posture 2. Which means here there's a bunch of 1s and 2s, and it may be tricky to figure out what on earth they mean. So I would recommend going back up here and reminding yourself that posture 1, congruency 1 is congruent stand, posture 1, congruency 2 is incongruent sit. So scrolling back down to here where we could look at our pairwise comparisons, what we can see is that we have over here within congruency being with congruent texts or congruent words with color, font, and word, sitting and standing does not make a difference. This is not a significant difference. However, if we look at standing, which I believe is, nope, sitting, sorry, got those switched around. Honestly, I write this down to help me keep track of it. Then we can see that there is a significant difference there. Now, it gets a little more complicated if you swap around those pairwise comparisons and you look at posture and levels of congruency within them. Because whether you're standing or sitting, you're going to have a difference with congruent and incongruent reaction times. So in this case, it makes more sense to think about how posture affects is different within congruency rather than how congruency is different within posture. And you can visualize this in the graph. You can see that within posture 1, the means are closer together than within posture 2. Again, posture 1 was let's scroll back up here, was standing. Posture 1 was standing, posture 2 was sitting. Another way to look at that is you can run that test again, and with your plots, you can say, you know what, I want to look at these the opposite way. So I want to look at how congruency looks different. Click add, continue, okay. And here, this shows more of a direct comparison with the incongruency, and you can see the differences within posture. You can also see how within congruent words, there really wasn't a difference between posture. It's the longer reaction times with sitting that are notable. Now, just to clarify, what you want to see is shorter reaction times as a sign of better cognitive flexibility and performance. You could also make a graph. This is where the world of statistics can be quite subjective because there are a lot of different ways that you can plot these things. So you could do a bar chart like this, and then you could look at the differences that way.